Hello, in this project, we are going to display our snake game, which is created by the Java. And in this project, we have defined the G frame, which is our screen, our window, which will be shown on the screen when we run and debug this project. And plus, there is extends G frame. So we will be ensured that we are extending the class of the G frame by our system. After that, we have public Java client, which initiates interface, and this interface is initiated, and we have added the game library, which is extended by the G and implemented by the action listener. Action listener is kind of a listener that listens our actions in the system. So, for example, when we done something, this will need to make actions. Okay. So now, in this game, we have set resizable to false, which prevents our window to be resized, and the spec method is used for the width and width of the objects will be in their preferred size to make sure that we have used pack method, which is extended by GFrame. And after that, we have set location related to null, and this will ensure that our window is located on the center of our computer, and set default close operation, which will be activated when we press the close button. And here is event quick invoke later, and this actually updates our interface after the higher priority functions are have done. So when we set all of our objects, classes, etc., this will be launch this code, and this will create new Java client, which is our public class extended by the GFrame. And when we set visible true, it will make our window visible. So when we look at the Java game class, we have some width, which is the width of the table, the window we will use, and there's dust size, which is size of the dust, width and height of the dot. This is all dots. This all dots is used for width and height implementation. For example, we have this one and this one. So when we look at the eye location, there will be some number in there. So in this situation, we have some x and y, and these components will define every part of the snake. For example, there are 300 multiplied by 300, which is 900, and when we define a snake in somewhere of the table, it will appear to be destination like x and y, right? The snake will appear in x and y. So this will ensure that when we apply this method, x0 is the head of our snake, and this will defines the position of the first head. So x0 is 50 in this situation, and I0 is also 15 in this situation. That means the location is 15 and 15. Okay, this will set us the situation, and there's timer which will ensure that there's some delay before the start, and this will be good actually. and there's ball, which is our ball, image of the ball, and there's apple, and there's head. And these are our structures. And there's dots, the dots are the number of the dots, apple positions, and this is the situation of whether we are going to left, right, up, or down. And after that, we initiate the board in the game public game class, public game as constructor, sorry, not class. And this is at key listener, which as our adapter to its key listener. When we press something, it will senses the pressing button. And this is set background, which sets the background of our window. And this is set focusable, which ensures that our frame will capture the case and the changes of the input on our window. And this is set preferred site, which sets the dimensions width and height. We have defined it in there, and this ensures that our table is 300 300. And this will load images, and after that that initialize the game. And the load images actually loads the ball, apple, and head, and after that it will be initialized, and this will set our snake positions, and this will be set like this. You will show me in the example, but this is head, and there is some space between there, and this is and these are the boundaries. For example, this our snake will be started in this position, but there's also other dimension, but I haven't shown it. And we will locate the apple. When we set our dots, we will locate the apple. We will start the timer, which ensures that this will be applied when our changes are done. And when we use this timer, this will ensure this, and timer.start. And actually there's override method paint component. This will draw, and actually this is the function of the R class when we call and run this frame. This will be worked. Okay. We have used our Cypher class, and we have pasted the parametric graphics G paint component, and after that we have started do drawing. Do drawing ensures that this will draw image of our apple firstly, and after that for every dot in our screen, this will draw our head and ball. Okay, after the apple is drawn. So after that, if in this is in game, this will be launched, and this will make the changes in every abstract. Sorry, in a lot of abstracts, because toolkit is a this abstract Cypher class, which means this has more than one children more than one children which uses this method. And when we do this, the abstract function will change their results. So this is the easy way of the updating our state in our graphic and our game. So if this is in game, this will happen, but if game is over, it will end. And how will we define if game is over or not? Actually, there is other function, overridden function, action performant, which means first we check the apple, we check the collision, and we move. If there's something in problem, some problem in there. If there's some problem in there, collision, which is here, check collision is here, and this will changes the in-game the variable of the in-game to false. And when it is set to false, this do drawing, which is launched by the override function, gets this is not in game, so this will be lost, right? Game over is launched. When game over, this will paint the other. This says color to white, font to small, which is Helvetica font bold. This is the font options. These are the font options, and g.drawString draws the message on the screen. So this is all of our functions, and last of but not and least, this checkable function, which checks if our snake is if our head is located on the same coordinates as the apple does. These dots will be increased, and there's locate apple function which changes the location of the apple. Locate apple. This will change our location of apple. And when checkable comes here, checkable also locates apple again. This is the locate apple. Okay. When it changes, it will draw again. It will draw again. Do drawing function. This is the structure of our game, and thanks for listening. But I will show you before the quitting the structure how the game works. Let's close this, and okay. Here you can see we will eat something. When we hit ourselves, it will be game over. In the other station, I will show you. When we hit the wall, it is game over. Okay. So this is all of that, and thanks for listening. Goodbye.